Hi, I'm Luke, ON7DQ, and behind the camera is Jill, ONL12523, who's the programmer of all the software in the Morse Box Project. If you haven't seen our introductory video, go to the YouTube channel and watch that video first. This time we will look at more detail of the basic operation. In another video we will have the extended operation and the Windows program. Check the YouTube channel for those videos as well. Now let's have a look at the block diagram first. The main component of this project is the Arduino Nano, which you see here. It contains all the firmware that does the magic work. Make sure you always have the latest version of the firmware, even if you make only the basic version, because some of the things are improved in later versions. If you want to make a minimal setup, you would need an Arduino Nano, at least one keying input, an audio amplifier, and the relay with associated transistors, and you have to wire a jumper block, which we'll talk about later, for your brand of transceiver. Remember that some of the things that we will discuss are optional. All details can be found in the manual on GitHub. The manual is available in English, in Dutch, and even in Spanish. Let's start in the block diagram on the left side. You have a couple of inputs here. You can connect 5 volts, or 9 volts, or even 12 volts with a voltage regulator to power the circuit. Or you could power the Arduino Nano via the USB connector, if you like. If you connect it to a computer, you will have power over the USB connection. You can use your 13.8 volt transceiver supply, but beware of extra noise that this may introduce, so you may need some extra filtering on the input of that power supply. Next are a couple of inputs for key, straight key or bug or QT key, a paddle, single lever or a dual lever paddle, whatever you like. And you have even the input for a touch paddle. This is built in the circuit, all is done in software. All you need to provide are 2 contacts, and the manual shows you a simple example of how to make this with 2 pieces of printed circuit board. Then several buttons and switches can be connected. It's shown with one line here, but you can connect the buttons for sending beacons, for sending memory messages, for sending random groups, and all these things can be shown later. The message for the beacon and the timing interval can be programmed from the serial monitor of the Arduino. If you don't have that, you can also use the Windows program, which we'll discuss in a separate video. Of course, then you have a few potentiometers or controls to set the side tone volume, the PTT delay, and the word per minute speed of your keyer, which is also built into the Arduino. The PTT delay can be set between 1/2 second and 10 seconds, and the speed can be set from 10 to 35 words per minute. Now you may ask, why not slower than 10 words per minute? We are convinced that if you want to learn CW, you shouldn't learn it with very slow word per minute characters. Try to learn CW at a high speed, but increase the character spacing. We will show later how to set that in the software, and this character spacing is called the Farnsworth spacing. And what about the top speed, 35 words per minute? We are convinced that sending faster than 35 words per minute is not for beginners, so you better make another keyer for that. The last input here at the left side is the test jumper. It can be shorted when you start up the Arduino, and you will then enter a special test routine which will show on the display and in the serial monitor the values for the touch keyer, the timing values, which might help you solve some problem if your touch keyer is not working as you think it should. Make sure you remove the test jumper and reboot the Arduino for normal use after you have done these tests. Below the Arduino you see 3 optional outputs. The first one is the keep alive circuit. If you want to use this circuit on a power bank, some of those power banks shut off automatically if you don't draw too much current. So in this case the transistor is switched on for the keep alive circuit, which will keep your power bank alive. It's not used very much, and it introduces a slight ticking in your speaker, so you can omit this circuit if you like. The other outputs are for two LEDs, a power LED and a PTT LED. If you want to see what they are, you can put two LEDs on the outputs there. Going further around, we see an OLED display, which is driven by I2C lines here. Very easy to implement, and very strongly advised to use a display because it shows some interesting information. It shows the parameters that you set, and it can also show the sent text and the decoded text, the answers to the random groups that you make, or the beacons that you send. So I think you cannot do without the display. Then you have some keying output with an optocoupler, which can be used to key an external transceiver, which does not have an electronic keyer, like an older model or something. Or maybe you have built a QRP rig or a beacon transmitter. All those can be keyed with our keying output. Next, you have the most important block in this thing. We call the jumper block. The jumper block is your interface to your transceiver and your microphone, and you have to take care that you do correct wiring. There are examples in the manual for all the brands of transceivers that you have, like Kenwood, Yaesu, Icon. Check the manual and be careful if you wire the jumper block. The output of the PTT line will put your transceiver into transmit. At the same time will activate a relay which makes the connection to your microphone or to the CW tone that you want to transmit. If the Arduino or the Morse box in a whole is not powered, the microphone will still be active and your transceiver will operate just normal like it used to be before you made these connections. Finally, you have the tone output, which is made by a direct digital synthesizer inside the Arduino. The tone output is put through a low-pass filter so that we have only the sine wave tone here, and then is amplified by an LM386 audio amplifier and put to an internal speaker, or there is a connection for an external speaker or for headphones. Okay, and now we will try this for real. First, let's check if the frequency is clear. QRZ, is anyone using this frequency? As you can see, the microphone remains fully functional. Of course, for transmitting CW on the air, don't forget to put the PTT switch in the on position. And now let's launch a CQ. that was a short QSO. And just let me remind you that we will have some other videos on the decoder section with more detail, also about the Windows program and using a serial monitor in some other video. Check out the YouTube channel and enjoy. 73s for now.